Okay, today's lesson is over functions. There we go. And I need you to have paper, pencil, and there's some notes here. At the end, we'll review. Then you're going to work on some Alex homework over functions. Miss Ziegler and I have talked on this. We're going to go through this quickly. So you're going to have to just take the notes and keep up with us for the next 2.5 to 3 weeks. And here we go, functions. What is a relation? A relation is an ordered set of ordered pairs x and y. It can be represented as a table, a graph, or a mapping diagram. And it's nothing more than what you see there. A list of all x values is called the domain. There's something you need to know. And y values are called the range. You're going to hear domain and range the rest of your math life. So you need to know domain is x, range is y. I remembered because D comes before R, X comes before Y. That's how I remembered. So, some things are a function, some are not a function. Look at the left-hand table. The X values don't repeat in a function. 1, 2. Every X has only one Y. Every X only has only one Y. The Y's can have as many X's as they want. So if you look down the table, every X has only one Y. Every domain has only one range. Every X has only one Y. Then you go to this side where it's not a function. There's an X with a 1, an X with a 1, and the Y has a 5 and a 2. So that 1 has 2, not a function. Here's one where 1, again, the domain, 1 has a 5 and it can't be a function. And this has 4, 4, 5, again, can't be a function. So what you need to get from this slide is being able to recognize what a function is and what a function isn't. And right now, I get it. These words are all, but we have to introduce it somewhere. It'll all come together as time goes along. So right now, I'm telling you the highlights, what you need to get from this. You need to be able to recognize when every X only has one output, every input only has one output, then that makes it a function. If any input has more than one output, then that means it's not a function. Also, we're going to be graphing these functions. This is called the vertical line test. And that'll be explained to you as time goes along too, but you can see if you can draw a vertical line up and down and it only passes through one point on the graph, it's a function. You'll be asked this on the test this year. They're going to show you a graph, ask if it's a function or not. These are functions on the left. On the right, those are not functions because the vertical line goes through more than one point on the line. So this U is a function. Turn that U sideways, it's not a function anymore. Try the vertical line test. So you can't actually draw on this, but if you were to draw your vertical lines, you see where it is, which one of these is not a function. Well, hopefully, and pause it for a moment if you need to, but hopefully you can see the one on the left is not a function. It does not pass a vertical line test. Excuse me. Pause the video and answer these questions. If X equals, this is how a function rule works. We're going to get more into what it actually looks like. But for right now, what we're looking at is how a function works. If X equals 0, let's do the red ones. Again, pause because I'm just going to go ahead. If X equals 0, then A will be 3. If X equals 2, A will be 7. Go to the green. If X equals 3, wow, Y is 13. If X equals 5, 5 times 5, Y will be 23. All you're doing is plugging in, you're evaluating. If it was an expression, you're evaluating it. You're solving it, plugging in the X's. And here, if R is -3, that's -6 plus 4 be -2. If r is -7, that'd be -14 plus 4, which would be -10. Okay. Then we have tables. And again, I would tell you to pause. I'm going to give you the answers here quickly. Okay, you're back. When C equals 6, half of 6 is 3, half of 12 is 6, and half of 24 is 12. That's the way I see that. You see it as a decimal, I see it as half. 44. So again, we're looking at the input. T's are output. C was our input. D's are output. If you're not catching this yet, the X's are the inputs and the Y's the output. That's what you know it as. But now we're starting to call it an input-output function tables. You did that back in 2nd and 3rd grade. They didn't call it this, obviously, but you did it back then. So what you know as X and Y now becomes input-output. So if the input is 44, on this one, the output's going to be 4. If the input's 132, the output's 11. And if it's 165, the output will be 15. If the input is 0, it would be 3, 1 would be 4, 2 would be 5, and 3 would be 6. Again, it's not trying to trick you, just letting you see how input-output tables work. Is a function linear? Is it going to be a straight line? And we talked about this before. If the rate of change is the same, if I could put, they keep putting 1/2, 1/2, and 1/4. I'd rather you see it as, anyway, that's fine. We'll go with that. 1/2, 1/2, 1/4. And you see the rate of change is not the same. If it's not the same, it's not a linear function. And we talked about that, oh, wow, before Christmas. And this one here, -1/3, -2/6, -3/9, they all simplify to -1/3. Therefore, this would be a linear function. And it does create a straight line as a linear function. Here's a picture of a nonlinear function. It's called a parabola. And it goes up, and it's obviously not a line. You're going to be dealing with that. Again, this is an introduction to it. Don't worry about even remembering the word. But when we do come back to a parabola, you'll know that, oh yeah, that's that curved line. Recognizing linear equations. We did this, y equals mx plus b. This is the standard form, ax plus by equals c. Those are linear equations. So this is no different. And we do know it's a linear equation, but it has no exponents greater than 1 and no square roots. Likewise, is a nonlinear equation, is a parabola, is a curved line if two variables are multiplied or divided. X, Y. If you multiply or divide, there's no way you're going to have a straight line. It has a variable for an exponent. It has an exponent greater than 1. B squared, B cubed, B to the 4th. That's always going to be a nonlinear equation. Or it involves a square root. Square root of x plus 5, then that would also not be, that would be a nonlinear equation. Again, not important that you understand the equations right now. It's important that you recognize that what can be linear, what can be nonlinear, and you'll see again as time goes along. So check your understanding. Pause the video and let's call one A, B, C, D, E, and F. Which ones are linear or nonlinear? Okay, we're back, and here are your answers. Linear, straight line. Linear because it's -2/3, -2/3, -2/3, -2/3. Nonlinear, it has an exponent greater than 1. Linear, it's y equals mx plus b. We know that's linear. Nonlinear because it's not a straight line. And again, 1/7, 1/19, 1/37. That definitely is nonlinear. Okay. 3 of these are linear and 2 of them represent nonlinear as words. Just another chance for you to practice this until you recognize one linear. John mows the lawn for $15 an hour. You can read them. I don't need to read them too. But 3 of them are linear. 2 of them are non. Don't look at the circles connected to the. They don't mean anything. Just read each situation. Pause it. Which 2 are nonlinear? Which 3 are linear? And we're back, and there they are. A cell divides into 2. Each cell, that would give you an exponent. That's what that's all about. And a child's on a swing. A function shows its height above the ground as related to time passing. If you saw the swing, you can see again it's going to go up and it's going to go down because the speed's going to be faster as he hits the bottom and slow down. So it's not going to be a linear equation, linear relationship. To review, domain, all the input values range all the output values. What's a function? The ones on the left are functions. The ones on the right are not functions because every input has only one output. On the left side, on the right side, that's not true. There are inputs with multiple outputs. That's what makes the difference between a function or not. A linear equation can be written in y equals mx plus b slope intercept. And if it's nonlinear, these are the 4 reasons why. It could be nonlinear. It would be nonlinear. Doesn't mean it's not a function. Functions could be linear. Functions could be nonlinear. Okay. Last thing I want to cover with you. You're going to read this f of x equals 15x or whatever it would be. And that's the way you read it, by the way. F of x, g of x, h of g, whatever it would be. You're going to substitute. I think of it this way. I see this as y equals mx. I wish the teacher in high school would have been Mr. Flora, would have been Mr. Price, actually, would have explained it to me. Never truly understand. What happens is, I want to make x something. That's the function of x. So function of whatever number x is, plug it in for x, and it's going to end up equaling f of x, which ends up being then y equals mx. And that's, hopefully you're seeing that. Let me take you to an example. You can organize your input in the function table. The domain's the independent variable, and the range is your dependent variable. Here's an example. Here's this f of x. So the function of x equals x plus y. When the function of x is -2, you would actually write that f of -2 equals -2 plus 5, which would be 3. I see this as x and y still. I see it as domain and range. But they're going to write this as f of x. So you need to know to write it that way. But maybe your mind takes you back and says, oh, that's really just y. If this was y equals x plus 5, we would do the exact same thing. So we're doing f of x, we're function of x. That's what it amounts to. The function of x, when x is -1, well, we plug -1 plus 5, we get 4. The function of x when x is 0, 0 plus 5 is 5. The function of x when x is 1, 1 plus 5 is 6. And then I give you one to practice on. I would encourage you to write this down. Fill in -1, make your x your range, domain. Make your domain, your x's, your inputs. Go ahead and make that -1, 0, 1, and 2. When I was in school, we only used 3. They want you to use 4, so I'm putting 4 up there. -1, 0, 1, and 2. You can make it whatever numbers you want. What you're looking for are numbers that when I plug them into x, it's going to give me easy numbers to work with. The book gave us examples of 7, 11, 17, and 23 or something, which that's way too much work. -1, 0, 1, and 2. Go ahead and find what f of x is. When x is -1, what's f of x? So you end up doing this. 6 times -1 minus 4. 6 times 0. 6 times 1. 6 times 2. And finally, -10, -4, 2, and 8. You're going to get a problem on Alex, that a couple problems that have you use a table, talk about f of x, the function of x. Again, don't get thrown by it. You can back to your notes, ask me, and that's what we got right now. Go to Alex and complete the functions practice. It's due by the beginning of Wednesday's class, but I hope you get it done before you leave today. I'm available from 1:30 to 2:30 today and tomorrow. If you run into problems, then you need to go ahead and um, log back in. Well, ask now. This you should have about, if I've got this timed right, about 45 minutes left in class. There's 10 questions. That's plenty of time to get through those 10 questions, 10 problems. So go ahead, hang with me, get this done. Go to Alex, and I am done. So I will see you on the Alex side of things.